13.2 is about multiplying and dividing powers. In this lesson, we are going to be developing 3 different rules. One rule for simplifying a product of powers, another for simplifying a power of a power, and lastly, a rule to simplify a quotient of powers. I'm actually going to skip over a lot of problem 1 because they go into some crazy stuff about megabytes and kilobytes. I feel like it's kind of overkill. The concept that we're learning today is actually very simple, so I want to keep it simple for you. So go ahead and flip to page 295, where you will see this girl talking about writing expressions with no exponent. And basically what she says here, I want you to highlight it, underline it, circle it, whatever you need to do. Basically what she's saying is if you write an expression that has no exponent in it, it's basically giving the exponent of 1. So let me get my pen back here. Anytime you write an expression, for example, the number 10, if you just leave it as 10, that means the exponent is really 1 because 10 to the first power is the same thing as 10. So what this girl here is saying is actually important for you to remember. But again, I'm going to skip over a lot of problem 2 or problem 1. At the bottom of the page, problem 4 and 5 ask you to kind of go back over the things and try and figure out what you did in that whole section. The question is, how does the exponent in each product relate to the exponents in the factors? And what they want you to realize is that when you're multiplying the bases, you add the exponents. So I'll give you an example that's not as confusing as the book gave. So if you have 7 to the second power times 7 to the third power, you would have your answer is 7 to the 5th power. So again, when you're multiplying the bases, you add the exponents. So I just took 7 as my base, I added my 2 exponents, 2 plus 3, and got 5. On question 5, they ask, how do the exponents in a quotient relate? In this case, if you have 7 to the 4th power over 7 to the 3rd power, you would subtract your exponents. So my base stays the same, it's 7, and I take 4 minus 3 to get an exponent of 1. So again, if you have a product, you add your exponents, and if you have a quotient, you subtract your exponents. And we'll do a little bit more practice with it throughout the lesson. I just thought problem 1 was a little confusing for you, and I didn't want this whole concept to come off as difficult. So let's flip over to problem 2, and let's figure out why the product rule works. So if I have 2 to the 4th power times 2 to the 3rd power, I'm going to write it out in expanded notation. So I'm going to take 2 times 2 times 2 times 2, and that's for the first one, 2 to the 4th power, 2 times 2 times 2, 4 different times. And then I'm going to move on to my next one, and now I'm going to do it 3 more times. Oops, I almost wrote 3 for my last one. Okay, so if I count all those up, 1, 2, 3, 4, 5, 6, 7, I really have 2 to the 7th power. And you'll notice that if you take 4 plus 3, you get 7. Let's try it again with negative 3. We are going to take negative 3 and multiply that 3 different times. I then need to add on those last 2. And if I count them all up, I have 1, 2, 3, 4, 5, or I have negative 3 to the 5th power. And again, the same case here. If you take 3 plus 2, you get 5. Go ahead and try the rest of these with your group, and then when you're ready, press play, and I'll have all the answers up for you so that you can check them. Alright, so here are my answers for C, D, and E. What I did again was I wrote all of these out in expanded notation. So for letter C, I did 1A, and then I did 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Same thing over here for D. I did 2 M's, I did 2 P's, 3 more M's, and then 1 more P, and so on and so forth for letter E. I want you to try and do what this lady's asking you. She wants you to write these as single powers. So I'll do A and B with you again, and then I'm going to have you try C, D, and E on your own. Oh, I lied. I already did those for you. Okay, so here mine are in single powered form. You take the expanded form and put it back into power form. So you go ahead and try C, D, E. Again, push pause until you have your answers, and then push play to make sure that you got them correct. Okay, my answers are up here for you in the purple writing this time. Again, I just added up all my A's and I counted 9 of them, so I have A to the 9th power. Or you could have looked back at the original problem and added. Remember that any expression left alone really has an exponent of 1. So you could have taken 1 plus 8 to get your 9. On letter D, again, I counted my M's. I have 1, 2, 3, 4, 5 M's and 1, 2, 3 P's. Same thing, you could have looked back at the original, counted it up. 2 plus 3 is 5 for the M's. Anything with no exponent really has a 1, and then the 2 plus 1 would give you 3 for your P's. Last one, letter E, I had 9 to the 5th power and Y to the 7th power. Question 2 is what we already did up on number 1 when we went through and wrote those expanded forms into power form. 3 asks what the relationship is between the exponents in the original and then in the other ones, and it is the sum of the exponents. Again, because we talked about when you have a product of powers, you add the exponents. Lastly, number 4 wants you to write the rule, which was one of our objectives today. Write the rule that you can use to multiply powers. I want this to be put in your book. And I also want you to add it into the notes section of your binder. So flip open to the notes section, label it 13.2, and then make sure you write this in. The rule is to multiply powers with the same base, and that's important. They do have to have the same base. I must keep the base the same and then add the exponents. So that's the big thing. When you're multiplying powers, you add the exponents. Oops, I'm sorry. So go ahead and make sure that gets in the workbook, and it also goes in the notes section of your binder. So push play, because I'm going to keep moving on. When you have that written in both places, make sure you check your groups, make sure they're all doing it, put it in the notes section and your workbook. When you're ready to move on, press play again. Okay, hopefully you got that written in the notes section of your binder by now. Problem 3 is going to be talking about a power to a power. Sometimes a power can be raised to a power. The exponential expression 4 squared to the power of 3 is a power to a power. It can be written as 2 repeated multiplication expressions using the definition of a power. So here you'll notice that they took 4 squared 3 different times and multiplied it together. So they have 4 times 4 times 4 times 4 times 4 times 4. They then tell you that there are 6 factors of 4. So again, we're going to come up eventually with a rule for that to add to your notes section. But for now, I'm going to have you move down to number 1, and we're going to try some of them. It says use the definition of a power to write repeated multiplication expressions for each power to a power shown in the example. So if we have 8 squared to the power of 3, we can take 8 squared times 8 squared times 8 squared. This is eventually, if you write it out in expanded notation, it's 8 times 8 times 8 times 8 times 8 times 8. So you can count them up. You will notice you have 1, 2, 3, 4, 5, 6, or 8 to the 6th power, and you can probably already tell what we're doing with these 2 exponents. Again, you leave the base the same, and this time instead of adding the exponents, we do what? hopefully you see that we multiplied 2 times 3 to get 6. So let's try one more together and then I'll let you go on your own. In this case we have 5 to the 4th power and then to the other power of 2, so we're going to take 5 to the 4th times 5 to the 4th. If you write it out in expanded notation, 5 times 5 times 5 times 5, 4 times, and then you need another set because you're doing it to the second power. 1, 2, 3, 4. Mine are getting real squished here. If you count them all up, I end up with 1, 2, 3, 4, 5, 6, 7, 8, or 5 to the 8th power. And again, hopefully you notice that instead of adding 4 plus 2 to get 6, this time we took 4 times 2 to get 8. All right, go ahead and do C and D with your group. I want you to write it in all 3 forms. Okay, so get it out, J cubed 4 different times, write it out in expanded notation, and then put it back into powered form. So press pause while you get those done, and then when you have them completed, press play to check your answers. All right, here are my answers to C and D. You had to take J cubed 4 different times, and I got lazy and I didn't write all mine out, but it's J times J times J times J all the way 12 different times. And then this last one, D here, you had negative 2p cubed, and you had to multiply that 2 different times because they were taken to the power of 2. When you write it out in expanded form, I had negative 2p times p times p, and then I also had it one more time, negative 2 times p times p times p. And when I simplify it down and write it in your power form, it's 4p to the 6th power. Now I want you to look up at what this girl's saying. She says, so I can rewrite what our original problem was, negative 2p cubed, cubed, all taken to the 2nd power. She says, can I write it as negative 2 squared times p to the 6th power? And we've already said, yes, it can be simplified a little bit more because I know that negative 2 times negative 2 is positive 4. And then I can still take that p to the 6th power. But I want to ask you if there's a difference between this and 4p all to the 6th power. And you should hopefully automatically say, yes, there's definitely a difference between these two, because this 4 is really to the 1st power, and if you were to take 1 times 6, you would end up changing this to be 4 to the 6th power, p to the 6th power. And this answer is very different from this answer over here. So be careful and cautious when you're going through these types of problems where parentheses belong and where they do not belong, because it can definitely change your problem very quickly. All right, the next page asks you what the relationship is between powers of powers and the exponents between them. And hopefully you have seen throughout these examples that when you are taking a power to a power, you are going to multiply the exponents instead of add them this time. So power to a power, you multiply. 3 wants you to again write that rule. This rule I want to go in the notes section of your binder and in your book. So if you need to pause and take the time to do that, please do it. I'm going to be checking your notes when I get back, so don't try and get away without taking the notes. Put this in the notes section of your binder and in your textbook. When you have finished writing those notes into the binder, I want you and your group to work through A through I and try and get those figured out. Be cautious because some of these are products of powers, like 6 to the 4th power times 6 to the 3rd. With those, remember that we add exponents. And an example like C, we have W cubed all raised to the 5th power, and with products of power or powers to powers, we will multiply those two numbers. So be cautious because you kind of have a mixture of these going on in A through I. Push pause, work with your group to get these done, and then when you are all finished, press play and I'll put up the answers for you. Here are the answers to A through I. Please make sure you take the time to go through and figure out which ones you made mistakes on and how you made the mistakes. We had tried examples like A, B, and C together, but be cautious when you get to something like letter D. I had to take 2 to the 5th power, and that's where I got the 32 from. And then each of these variables, A and B, both had an exponent of 1. And if you take A to the 1st power times 5, you get 5. And B to the 1st power times 5, you get an exponent of 5 again. Here, I had to take all of my bases and multiply them together. Remember, anything with just a base is a 1. And then, again, I added all of my exponents. On letter F, don't forget that this M has an exponent of 1. And just kind of keep working yourself through. Big things to remember, that every exponent is a 1 unless it is otherwise specifically marked. Don't forget to be doing multiplication, like in this case on H, you need to take the 3 times the 7 to get the 21. Hopefully that went okay for you. Make sure you're asking Ms. Bunner questions. I'm sure she's able to help you on this. If not, we can obviously ask questions when I get back too. But keep doing your best to follow along with me and get these notes taken in your book. All right, we are on to our last rule of the day. This time we're dealing with quotients and powers. Number 1 says use the definition of a power to write each number, and each numerator and denominator as a product. So in part A, I'm going to do 9 times 9 times 9 times 9 times 9 5 different times. And on the bottom, for my denominator, I'm going to take 9 times 9 2 times because those are what my exponents are telling me. I can then go through and try to simplify. 9 divided by 9, it gives me 1, so those will cancel out. Same thing here, 9 divided by 9 will give me 1, and those will also cancel out. So the top, or my simplified version, has 9 times 9 times 9 left over, or 9 to the 3rd power. If you look at what's happening with my exponents, hopefully you're able to notice that 5 minus 2 gives me 3. So that's what I'm doing with my exponents, is I'm doing subtraction whenever I have a quotient or a division problem. So I'll try B again with you, and then I'll let you do C and D on your own. I have 5 times 5 6 times, and on the bottom, or my denominator, I have 5 times 5 times 5 3 times. Again, some of these will cancel out, and I will be left with 5 to the 3rd power. And you will again hopefully notice that 6 minus 3 would give you that 3 for your exponent. Go ahead and try C and D on your own. When you and your group are ready, press play to make sure you have the correct answers. Here are the answers to C and D. I have Z squared and U times U over Z, X. I'm used to using the Z from problem C. Number 2 wants you to simplify them back into your power form, and we kind of already did that here. A is 9 to the 3rd, B is 5 to the 3rd, C is Z squared, and then lastly, the simplest form of D would just be the original problem. There was nothing there to simplify. On the next page, we are going to eventually write the rule here. Again, they're asking what relationship do you notice between the exponents when you're dividing the bases. You should notice that we're taking the difference or subtracting. For a rule, again, please write this in your notes. To simplify a quotient of 2 powers, I must keep the base and subtract the exponents. So go ahead, push pause, write that down in your book and in your notes, and then come back with me when you're done. I'm going to have you try number 5 on your own with your group. Again, when you're dividing powers or bases, make sure that you subtract exponents. And notice down here too, when you have regular plain old numbers, you can take 12 divided by 2 to simplify that as well. So go ahead and try those with your group. Push play when you're ready, and I will get you some answers. Here are the answers to number 5. I hopefully you read what this guy was saying here. He says that having the same base is important. We said that in the rule. You have to keep the base the same. You can't go changing the bases. So hopefully for part C here, you remembered that you couldn't just take 3 minus 2 because your bases were not the same. However, you could still simplify it a little bit. And again, here, like I told you in part D, 12 divided by 2 could be simplified down just to regular 6. Just like with the multiplication of your bases, this x has a 1 on it, so 4 minus 1 then became 3. All right, I'm going to have you discuss problem 5 with your group. When you get done with problem 5, you can move on to Talk the Talk. I want you to complete all of Talk the Talk with your group. And when you have all of Talk the Talk done, then you can press play and I will put the answers up for you so that you can check over the answers to make sure that you guys are on the right track and doing well with everything. I also have a little note about the homework assignment for tonight, so make sure that you get this done and press play before you leave class. This little Talk the Talk box is awesome. It has all your rules in one place. If you need to go back and check those rules, they should now be in your book. They should be in your notes. And now you also have this awesome little table here with the definitions and the examples of the rules right here all in one place. So that's awesome reference for you to look back upon. Again, you should have done all of these questions on number 1. If you have not yet, push pause again because I'm about to put up the answers and I want you guys to try them on your own first. Here are the answers to number 1, A through I. And then again, you should have, and if you need to rewind to get those answers, you can. But then you should have also gotten done with this question number 2. And again, if you have not, push pause. I'm going to flip those answers up here in a second. And here are those answers to number 2. So again, talk it out with your group. Make sure you guys know what's going on. Think back to those 3 rules that we just came up with today. If you are multiplying your bases, you add your exponents. If you're taking a power to a power, you multiply your exponents. And lastly, if you're dividing your bases, you subtract your exponents. So those are the 3 rules or the 3 goals we were trying to hit today. Good news for you, there is no homework for today. The homework tomorrow night will kind of review all of this topic, and I thought that the homework was just, they got into the kilobytes, millibytes thing again. So we're going to skip over that. So enjoy your night off with no homework.